All right, guys, so for this set of notes, we're going to make 3 or 4 videos to cover the properties of real numbers, okay? We're going to go over the different sets of numbers on the real number line. We're going to go over the properties of real numbers. We're going to go over the properties of negatives, and we're going to go over the properties of fractions, okay? And we'll talk about the order of operations in here too, okay? I'm going to make 3 or 4 videos just to kind of keep the video short and sweet, okay? So first off, we're going to go over the properties of real numbers, okay? So first thing we want to talk about is the commutative property. All right, commutative property, the order in which you add 2 numbers is irrelevant. Okay, notice a plus b is the same as b plus a. And just putting a numerical example to that, let's say a is 4 and b is 7. Well, it doesn't matter the order in which you add those. You're going to get 11 either way. 4 plus 7 is 11, and 7 plus 4 is 11. Okay, so that's the commutative property of addition. It doesn't work for subtraction. Okay. The commutative property works for addition here, and then multiplication in number 2. All right. Commutative property of multiplication, same kind of thing. Let's say a is 8 and b is 5. Well, it doesn't matter the order in which you multiply the 2 numbers 8 and 5. You're going to get 40. Okay. So commutative property works for addition, but not subtraction. Commutative property also works for multiplication, but not division. 8 divided by 5 is not the same thing as 5 divided by 8. Okay. So that's the commutative property. Now, if we expand that a little bit, we come up with what's called the associative property that works for both addition and multiplication as well, okay? In the associative property here, we've got 3 numbers, A, B, and C. Well, it doesn't matter how you group those numbers together, you're still going to get the same sum, okay? And this works for more than 3 numbers. You could have 10 numbers. It doesn't matter how you add together any of those 10 numbers, you're still going to get the same sum because the associative property is true, okay? So let's say A is 2, B is 6, and C is 9. Well, let's say I group the 6 and the 9 together first. Well, 6 plus 9 is going to give me 15, and then I add this 2, then that gives me 17, okay? So this left side is equal to 17, okay? Well, on the right side, let's say I want to group the 2 and the 6 together first. Well, 2 plus 6 is 8, 8 plus 9 is 17, so this kind of proves to us that when we're grouping in addition, it doesn't matter how you group the numbers, you're still going to get the same sum, okay? Again, this works for addition, but not subtraction. Associative property of multiplication works much the same way, okay? Let's say A is 3, B is 5, and C is 7. Well, if I want to group together 5 and 7 first, 5 times 7 is 35. 35 times 3 is 105, okay? Let's say I want to group the 3 and the 5 together instead. Well, 3 times 5 is 15. 15 times 7 is 105. So even though I group the numbers differently, I still get 105. Also, if I wanted to group the 3 and the 7 together, I could do that. 3 times 7 is 21. 21 times 5 is 105. Okay, so the associative property works for multiplication, but not division. Okay? Distributive property. We've got a term out here, A, multiplied by the sum of 2 terms in here, B and C, okay? So if I've got 4 times this sum, x plus 5, I can just multiply 4 times x, and 4 times 5, 4 times 5, okay? Additive identity property. The identity property just means that we get what we started with, basically. Identity means the same or self or something like that, okay? So the additive identity, if we want to add 0 to any term, we're going to end up with that term, okay? So 3x plus 0 equals 3x, additive identity. Multiplicative identity, again, we want to get what we started with. A times 1 equals A. Well, if I multiply something times 1, I get what I started with, 5y. You're going to use this often to solve equations, okay? Additive inverse, it's just basically adding opposites, okay? We're going to end up with additive inverses. We're going to end up with 0 as our answer. When we add opposites, those opposites cancel out, and our sum is 0. Multiplicative inverse, we're going to multiply reciprocals here. We've got a times 1 over a. That's going to always be equal to 1. Again, we're going to use that a lot for many different types of problems. So when we multiply a term by its reciprocal, we're always going to get 1. Okay, so 7x times 1 over 7x equals 1. One thing you have to be aware of, this denominator cannot be 0. If that denominator is 0, the whole thing becomes undefined, okay? So we would have to say here that 7x or x can't be 0, okay? So that's the properties of real numbers.